All right. I hope you guys are all doing well. What I wanted to do is go over a few basic integration rules with y'all. This is homework from my class. We're doing just a few of them. I just go over this to make sure my students have a okay understanding, or if they missed the day that we went over homework, they can get some of their questions answered. This section's right after we learn all the rules of integration. We are just now going to the application part. We're also learning integration by parts and the last couple of techniques. And so that's where we're at. This portion right here, 7.1, goes over how to identify which of the integration techniques or rules you need to use to apply it to your problem. Right now, we have quite a few that we can do. You have a couple that you're looking for. Which ones can we use specifically is what you should be asking. We, of course, want to use the easiest method we possibly can. We go through and call it a few different things, but generally, you have the chain rule. Most people go through and they just do use substitution. But in my class, we do use substitution just when we have to. How did I spell substitution wrong? S-T-I-T-U-T-I-O-N. Use substitution. Also, we have our trig identities, our trig rules. We have, on top of this, we have ln. And we have a few others that we're looking for. So we have to ask, is there a way that we can go through, or are we going to have to use an ln? Does it fit the ln method? Does it go through and if it's a trig property, does it go through and do you have a function inside of a function? Do we have a function inside of a function such as g prime of x times f prime of g of x? Do we have a function in this terms? If we do, we have to fix it. And we're going to go over this just as we go. We're going to talk about a few different ways to identify which trig rule or which integration rule we're supposed to use. And then sometimes we're also just going to have to rewrite or reduce before we can actually do anything. And so we'll go through a few of these. I think I have a few planned. We have 6 problems that I've planned that I'm going to go over. I'm going to try to be as organized as I can as I go through it. All right, first off, when you're looking at this problem, we don't have anything of the form u prime over u. If you're looking at this, we have a function f or 5x minus 3 inside of another function, so that leads me to believe we have chain rule. And so when we're looking at it, we have to ask ourselves, do we have the derivative of the inside outside of the function? Because we want it to look of the form g prime of x times f prime of g of x. Right now, we have f prime of g of x here, but we don't have g prime of x. So what's the derivative of 5x minus 3? Well, the derivative of 5x minus 3 is 5. So what we're doing is we're putting a 5 here, but we can't just randomly multiply by 5. We can multiply by 1, and how we do this and how we fix it is we put a 1/5 on the front. So this is identified as a chain rule problem. Chain rule, most people or most schools, from what I understand, use substitution when they're doing this. We do that when we have to. We're just going to fix it and go along with it, okay? So this is a g prime of x times f prime of g of x, okay? When you do a problem like this, we have to identify what our f prime is. F prime of x is just x to the 4th. So all we're going to do is integrate x to the 4th once we have this fixed, okay? So once we go through to integrate this, we're going to get 1/5 times the integral. We have g prime times f prime of g of x. And we just integrate f, so we're going to integrate x to the power 4. And when we do that, just power rule. We get 5x minus 3 to the power of 5. So we're just integrating this, right? Over 5 plus c. Okay, and that's essentially it. We can make it look nicer. We're going to get 5x minus 3 to the 5th over 25 plus c. And that's all she wrote. That's all we have to do. Okay. This next problem, however, there's something that you guys should be looking for. First thing you guys go through and you ask yourself, is this an ln problem? Do we have our derivative on top? So the derivative of the denominator, 2t minus 1 to the power of 2, is going to give us 2 times 2t minus 1 times the derivative of 2t. We only have a 2 on top, so it's not ln, okay? The next thing we ask, is there a chain rule? The derivative of the inside of this function is 2t, but we have this 4 out here. Does that change it? Can we rewrite this to make it look nicer, and then we can actually go through and do that? Because of this plus 4, we're having a slight issue. If this 4 wasn't here, this would just be a basic chain rule problem. But since we have that plus 4 there, it's a little different. It's not necessarily the same. So we don't have ln, we don't have a chain rule, so then we ask ourselves, does it fit one of the forms of trig? With the plus in the middle, I'm starting to think that it looks like arctan, okay? Arctan, we know arctan of u over a, I guess it's 1 over a times arctan of u over a. We know this is the integral of du over u squared plus a squared. Okay, and so we have to ask yourself, does it fit this form? Well, we have something squared, and this is also something squared. We can rewrite it to make it look more like it. We're going to have 2 over 2t minus 1 squared plus 2 quantity squared. So it actually is an arctan problem. And we have to ask ourselves, what's our 1 over a, what's our a, and what's our u? Well, in this case, our u, let's see, do we have the derivative of the inside? Do we have du? Du is the derivative of the inside of this function. Well, 2t minus 1, if we take the derivative of that, we're going to get 2. So it actually does fit this form. It fits just perfect. So we don't have to fix, we don't have to do anything there. So we're just going to go over here and write u equals 2t minus 1. Okay, a equals 2. And so we know that this right here is just going to become 1 over a, 1 over 2, arctan of 2t minus 1 over 2 plus c. And that's it. That's all we have to do. All right, this next part, we're going to go ahead and take a look at it. What I see right here is I have a function inside of a function, so right away I'm looking for g prime of x times f prime of g of x. I'm looking for chain rule, okay? Or you can always go into use substitution. So from this, let's take a look. Well, my outside function here is sine. That's f prime. So f prime of x, or t in this case, is sine of t. Let me make that a t just so it's not confusing with the change of variables. T is sine of t. That's the outside function. The inside function is t squared. G of t is t squared. Well, g prime of t is 2t. So let's see if it fits this form. So I need to have g prime. G prime is 2t. All I have in front is t. So that means I need to put a 2 here, multiply by 2, but I can't just randomly multiply by 2. I have to multiply by 1. So I have to cancel out multiplication by 2, which is division by 2, or multiplication by 1/2, because it cancels it out. Okay, so right now I have g prime, that's good. F prime of g of x, that's good as well. When you go through and you integrate this, you're just going to integrate f prime. So we're just going to integrate sine. Well, the integral of sine is going to be cosine, and we have to think about the sign. Is it going to be negative cosine or positive cosine? Well, if we go through and assume that it's just cosine of t squared, what we're going to do is go through and then think, if I take the derivative of this, is this going to give me positive 2t, or just t times sine of t squared? Well, the derivative of cosine is negative sine. There's a negative here. So that means I'm missing a negative. So this, instead of being cosine of t squared, it's negative cosine of t squared plus c. And when I go to make this look a little bit nicer, I'm going to get negative 1/2 cosine of t squared plus c. And that's it. Okay. This next one, we have to go through our rules. Once again, we have to figure out exactly what's going on with it. And it has to fit one of our forms, okay? So when I'm looking at this first off, it looks like it's going to be an arcsecant problem, but it may or may not. It really depends on what we're doing with this. So first thing I always go and ask, do we have an ln? Okay, well, the derivative of x squared minus 4, if I set it equal to that, let's think about it. If I go through and think about having u prime over u, okay, u is equal to x squared minus 4 to the 1/2. That would be this portion right here. And then we're going to see if we're left with 1 over x. Let's see if that actually works out. If I take the derivative of this, I'm going to get 1/2 x squared minus 4 to to the negative 1/2, okay, times 2x. That doesn't work out. This isn't an ln, okay? Then I have to ask myself, do I have a chain rule problem? Do I have f prime of g of x times g prime of x? Do I have something like this? Do I have chain rule? Well, if I set it equal to that, let's rewrite this first off. I'm going to have the integral of x to the negative 1 times x squared minus 4 to the power of negative 1/2. Well, that's not going to be a chain rule problem. So why is that? Because the derivative of the inside, x squared, is going to be 2x, and we have x to the negative 1 power. So it's not going to follow that. So now we have to ask ourselves, is this actually going to be one of our trig rules? So from that, what we have to do is we have to think about which one it's going to be. Well, it's not going to be arc sine, because we know arc sine of u over a, we know that that is the integral of du. There's, of course, a plus c there. I just didn't write it. Du over the square root of a squared minus u squared, I believe. Let me check to make sure that's right before I say that 100%. The order of them is always a thing I have to think about. So let's go the integral. All right. Yeah, it's a squared minus u squared, so that works out just fine. Okay. And so it's not going to follow this form, but this is going to be one of our secant problems. So we have to think about what secant is. So we know it's not arctan. We looked at that earlier. I have to have a plus. So this is going to follow arc secant of u over a. All right, cool. So when we rewrite this, this is the integral of du over u times the square root of u squared minus a squared. And that's where this all comes from. So we don't want to have this rewritten. I don't know what I just did. There we go. We want it to be of this form right here. Okay. Well, first off, a is going to be 2. U is going to be x. And the derivative of u is the derivative of x, which is just 1. So this fits the form just fine. This entire thing is going to reduce to arc secant of u, which is x over 2 plus c. Okay. Is there a 1 over u in front of it? I should have had this up when we started. All right, and that's about it. Okay, let's go ahead and move on to the next one. Okay, here's the next part. You go. First thing you ask, is this going to be an ln problem? Do we have u prime over u? Well, we know the derivative of the denominator is going to be 7. U would be z minus 10 to the power of 7. We bring this down, u prime would be 7z minus 10 to the 6th. So it's not an ln problem. So we ask ourselves, can we rewrite this? Would it look nicer in another form? So let's go ahead and rewrite it. Let's bring the z minus 10 to the power of 7 up to the top into the numerator. And this looks like now it's going to be a chain rule. The derivative of the inside, right here, the derivative of the inside is 1. So this 7 right here, we're going to pull out to the front of our integral. We're going to have 7 times the integral of z minus 10 to the power of negative 7. Now here, we just have to go through and we have to integrate. So let's go through. Basic integration problem, power rule. The derivative of the inside is 1, so there's no fixing we really have to do. And so let's go through and do it. We're going to get 7 times z minus 10 to the power of n plus 1, so negative 7 plus 1 is negative 6, over negative 6 plus c. And that's it. If you guys want to rewrite it to make it look nicer, we can write negative 7/6 z minus 10 to the power of negative 6. We can even put that in the denominator if we really like to. That's it. Okay, here's our next one. This one right here, we ask ourselves, does it fit ln? Do we have u prime over u? First off, the derivative of x minus 1 is not x squared, so ln does not work, okay? Then we ask ourselves, can we rewrite this to make it look like anything? Because it doesn't fit tangent, it doesn't fit arc sine, it doesn't fit any of those. So does it look like a chain rule? No, not necessarily. We can bring up the x minus 1, but that doesn't work. So this is probably going to be a rewrite problem or a use substitution problem where we actually have to go through and try it out. It looks like in this case the denominator is smaller by a power of 1 than the numerator, so we're going to go through and we're going to divide. We're going to do long division, okay? So let's go through and do this first. We're going to rewrite this x squared plus 0x plus 0. You want to put a placeholder whenever you're dividing. And so when we do this, we need a number that multiplies by x to give us x squared. So we're going to multiply by x, 1x, and we're going to get x squared minus 1x. And we're subtracting these, so we change the sign as we go. I'm going to distribute this negative, and what ends up happening is I get 0, these cancel, plus 1. Bring down the next 0. So now we have to cancel this as well until we can't cancel anymore. So what do we multiply 1x by to get 1x? Well, by 1. So we're going to bring this down, 1x minus 1. And we're going to subtract these. So this requires us to change our signs. We're going to distribute the negative, change all of our signs, and we end up getting 0 plus 1. So what this means is we have a remainder of 1 over x minus 1. Okay. So now that we have this, we now can rewrite the integral of x squared over x minus 1 dx as the integral of x plus 1 over x minus 1 dx. Each of these integrals is pretty simple. We have two power rules and we have a just basic ln. This fits the form u prime over u because the derivative of x minus 1 is just 1, and that's in the numerator. So what we end up getting is we get x squared over 2, x to the power of n plus 1 over n plus 1, plus x to the power of 1 over 1, plus ln of the absolute value of x minus 1, plus c. And that's it. All right, on to the last problem. All right, now this one's going to take us a little bit. This is either going to follow the method of ln or it's going to follow chain rule. First thing we have to do, if u is equal to the square root of cosine, all right, cosine to the power of 1/2, we're trying to check if it's ln. If we take the derivative, we're going to get 1/2 cosine of x to the power of negative 1/2 times negative sine of x. That is definitely not an ln problem. So the next thing we do is we go and say, okay, can we rewrite? Can we rewrite and then make it look like it's a chain rule? Because I know the derivative of cosine is going to give us sine, but it should be negative. So let's go ahead and see if we can rewrite it. So let's rewrite this as sine of x and bring up cosine into the numerator. So times cosine of x to the negative 1/2. Okay, well now I know that this is going to follow the method of g prime of x times f prime of g of x. And why is that? Well, I know the derivative of cosine is going to give me negative sine. I know f prime is going to be x to the negative 1/2. That's the outside function. The inside function, g of x, is equal to cosine. And I know the derivative of cosine is negative sine. So the issue I'm running into here is I need to put a negative. I need to put a negative here, but I can't just randomly multiply by a negative. I also have to multiply by a negative on the outside. So I'm going to put two negatives that cancel out. And when I integrate, I just integrate f. So if I integrate f, I'm going to get cosine of x to the power of n plus 1 over n plus 1. Well, in this case, it's negative 1/2 plus 1, so I get 1/2 over 1/2. And I forgot that this negative right here comes. Once again, whenever you have a chain rule problem like this, you have to, once again, the g prime of x goes away, and you just integrate f prime. That's all you integrate. Plus c. And that's all she wrote. Have a great one, guys. Okay.